So here I have drawn a 3-bit. Let's quickly do this. A3 and B3 both high, that means the generate is going to be high, and if generate is high, we know that C3 is high irrespective of what's present here or here or here. So that's case 1 done. Case 2, A3 and B3 are alternating. If that's the case, that means my G3 is 0 because they both are not 1. Because they both are alternating, that means my propagate signal is high. So this guy is propagating. At the same time, I am seeing that A2 and B2 both are high. So if that's the case, my C2 would be 1 irrespective of my C1 again. And here we know that C2 is 1, but we saw that when propagate 3 was high, that means C3 was equal to C2. In simple words, my C3 is also equal to 1 here. So we saw 2 cases. Let's see the final case. The first case was S like 2 bits, MSB generating or MSB propagating and the middle bit generating. Let's see the third case quickly. Here it says that A3 and B3 both are not same and A2 and B2 are also not same. If that's the case, we know that this generates will be 0 because they are both alternating, so the respective propagates would be high. Because P3 is high, that shows that C3 is equal to C2, C out is equal to C in. Propagate is high, so C3 is the C out and C2 is the C in. C2 equal to C1. But now we see that A1 and B1 both are high. If that's the case, generate 1 is high. And because generate 1 is high, they are mutually exclusive. Propagate has to be 0. Or because A1 and B1 both are 1 and they are not alternating, propagate is equal to 0. And we don't need to wait for C0. We can straight away say that my C1 is equal to 1. That means my C2 is equal to 1. That means my C3 is equal to 1. In nutshell, what we just saw right now was my C3 is equal to 1 if my group generate is high, and group generate is high is nothing but G3 is to 1, which says that if my third block is generating or my third block is propagating, this is propagating and this guy is generating, second block, or my third and second block both are propagating whereas my first block is generating. In this case, my G3 is to 1 is going to be equal to 1 and that will make my C3 equal to 1 without being dependent on the input carry. Cool. Let's do the last case. If A3 and B3, A2 and B2, A1 and B1, all these are ANDs, okay? If all of them are not same, we can easily say that my G3, G2, G1 all are zeros. However, because all of them are alternating, all my respective propagate signal P3 is going to be 1, P2 is going to be 1, P1 is going to be 1, all are going to be 1, which clearly says that my C3 will be equal to C0 because this guy is propagating, this guy is propagating and this guy is propagating. That is nothing but P3 propagating, P2 propagating and P1 propagating. So this gives us group generate and group propagate for 2 bits and 3 bits. Now we can generally write it for 4 bits because we are going to enter into carry look ahead adder now. So G4 is to 1 is if the 4th bit is generating, or if the 4th bit is propagating and the 3rd bit is generating, or 4th and 3rd both are propagating and 2nd bit is generating, or 4th, 3rd, 2nd all are propagating and the 1st bit is generating. If this is satisfied, then my G4 is to 1 is going to be 1 and that clearly shows that my C4 would be 1 and I don't have to depend on anything else. P4 is to 1 says that my C4 would be equal to my C0 if all the 4 blocks are propagating, which is nothing but P4, P3, P2 and P1. If all of them are propagating, that clearly shows that my group propagate signal is high, and if my group propagate signal is high, my C4 would be equal to C0. So I think let's translate this group 4 is to 1 generate and propagate into the gate level diagram.